Welcome. Today we're going to be talking about perimeter and areas of similar figures. A little bit of a definition to get us started. If the scale factor of two similar figures is A to B, and you'll recall that this is the side length of one figure to the side length of the other figure, then the ratio of the perimeters is also A to B, and the ratio of their areas is A squared to B squared, because area deals in square units, so we square each side. So for the first example, the trapezoids at the right are similar. The scale factor of the smaller figure to the larger figure is 6 to 9, because we have 6 meters to 9 meters for their corresponding sides. If we reduce that, we get 2 to 3. What is the ratio, smaller to larger, of the perimeters? Well, that's the same as the scale factor, so it's also 2 to 3, and we can either write it as a fraction or in the form of a ratio with the colon in the middle. Now, what is the ratio smaller to larger again of the areas? We're going to take our scale factor of 2 to 3, and remember, we're going to square each number. So 2 squared is 4, 3 squared is 9, and again, we can write it either as a fraction or in this form. We can use this concept of scale factors to help us find the areas of similar figures if we know one of them, but not the other. So in this example, I have two pentagons that are similar, and I know the area of this smaller one is 27.5 square centimeters. I want to find an approximation for the area of the larger one. Well, if we start by finding a scale factor, the smaller side, or the smaller figure to the larger figure of 4 to 10, and we reduce that to 2 to 5. Now to use that for area, remember we have to square each side, so we have 2 squared to 5 squared, or 4 to 25. So this is actually our scale factor for our areas, and we can use that to write a proportion to find the missing length. Now my smaller figure is 27.5 square centimeters. My larger one is unknown. That's what I'm going to solve for. To solve this proportion, we cross multiply, so we have 4x, and then we do 27.5 times 25, and we get 687.5. Divide both sides by 4, and we get 171.875. But again, we just want an approximation. I don't need that exact, and that's not really a pretty number. So I'm going to approximate. I'm going to round it to the nearest integer. So we get 172, and my unit is in square centimeters. We can also use this to predict yield. And in this example, we have a group of high school students who have cultivated a plot of city land, and they managed to harvest 13 bushels of vegetables from that they then donated to a food pantry. Next summer, the city is going to let them use a larger, similar-shaped plot of land. In the new plot, each dimension is 2.5 times the corresponding dimension of the original plot. So let's talk about that first. Here's my original plot. Now I'm assuming since it's a garden, they're probably working in a rectangular shape. I'm going to call this side length x, this side length y. I don't know what those are, but it's really not that important in this context. My new plot of land that I'm going to use next summer is, each dimension is 2.5 times. So this dimension is 2.5 times my x. This dimension is 2.5 times my y. So my scale factor from the smaller one to the larger one is 1 to 2.5. Now if I use that for area, because since we're dealing with bushels, we want to look at, how many plots of land here, how many different little areas can I put vegetables compared to this one to get a better yield or a larger yield. So we're going to square each side, so 1 squared is 1, 2.5 squared is 6.25, and we use that to write a proportion. So 1 is to 6.25 as 13, because that was my original yield in the original plot, is to x number of bushels. Cross multiply, I get x equals 81.25. So that tells me that next year the students can expect to have a yield of about 81 bushels. A little more, a little less, but approximately 81 bushels, which is not bad. In example 4, problem 4, we have two triangles that are similar. We want to find the scale factor and the ratio of their perimeters, and we're given the area. So let's write the scale factor for the area. So we have 50 to 98. Well, that will reduce because 2 goes into both of those. We have 25 over 49. Those are both perfect squares, which is really nice. We have 5 squared and 7 squared. So the scale factor, because remember, when we're dealing with areas, it's the numbers squared, so the scale factor is going to be 5 to 7, and the ratio for the perimeters is the same as the scale factor, so it's also going to be 5 to 7. Number 5, we have 2 similar rectangles. The first one is 1,875 square feet. The second one is 135 square feet. And we want to find the ratio of the perimeter. So we're going to do the same thing we did up here. And we're going to start by writing the ratio of the areas. And we're going to reduce what we can. Now I notice that both of those numbers happen to be divisible by 5. So if I divide them both by 5, I get on the top 375 divided by 27. Now I also noticed that this one on the top is divisible by 3, as is the bottom. So if I reduce it even further, I get 125 over 9. And if I look at that in terms of perfect squares, this would be 3 squared. This one, if I do the square root of 125, then I have 5 square root of 5. Okay, if you're not sure how we did that, we get 125 and we make our factor tree. So we have 5 times 25. 5 is already a prime number, so we stop on that one. 25, we get 5 times 5. Okay, so I have 3 5s. One pair of 5s is going to come out of my radical. The other 5 that's all by himself stays underneath. So we have 5 times the square root of 5. And remember, it's squared because we just took the square root to find out what this would be for perimeters. So the ratio for my perimeter of these two figures is 5 radical 5 to 3. Now we could also have done it the other way, where we put the 135 on top and the 1875 on the bottom, which would end up flipping this final ratio. Whichever way you go doesn't really matter, because we weren't directed to go larger to smaller or smaller to larger. That's it for today. We'll come back and start talking about area again in the next lesson, and we'll go back and review some of those formulas as well.